The last video, I think we got cut off a little bit talking about that last single replacement. So the iodine in this reaction is not able to replace the bromine. So I'd write no reaction, and that's because iodine is lower than bromine in the activity series, so it's not reactive enough. Another one of the types of reactions is double replacement. Double replacement reactions happen because of either you're forming a precipitate as a product, a gas, or water. So I'll show you how to predict products. When you have a double replacement reaction like this one, like silver nitrate, silver is +1, nitrate's -1, potassium chromate, potassium's +1, chromate's -2. And what happens is the metals, or the cations, essentially switch spots. So then I form two new compounds, and I'm going to be thinking about their charges. So I'm going to have a compound with silver and chromate, and I'll have one with potassium and nitrate. So notice that I'm putting the cation first, and now I'm going to balance charge. So this would be silver, there would be 2 of them, and potassium nitrate is just KNO3. So you can see that I don't bring the subscripts with, and then unless it's part of the polyatomic ion. And then I look at charge and I rewrite those compounds after those ions have switched. So that's double replacement. And then we do have combustion reactions. Combustion reactions are always going to be a hydrocarbon. And sometimes they'll have oxygen, but a lot of times they'll just be carbon and hydrogen. In order for something to burn or combust, that needs to have oxygen. And then your 2 products are always carbon dioxide and water. So an example would be C5H10 is our hydrocarbon plus oxygen. And then we're going to get carbon dioxide and water. And then if you remember, when we balance combustion reactions, I recommend that you go in this order, which I call this CHO. So go balance carbon, then hydrogen, then oxygen. So you can see carbon, there's 5, so I would have to put a 5. Hydrogen, there's 10, so I would need to put a 5. So now I'm ready to balance the oxygen. I have 10 oxygens and 5 for a total of 15. So I have an odd number of oxygens, so I'm going to have to use a fraction. I'm going to multiply this by 15 halves. And this is balanced, and you can leave it like this. You can also get rid of the fraction by multiplying all of the coefficients by 2. So this would become a 2 now instead of a 1. The 15 halves would become 15. And then the 5 would become a 10 for both of those. And this is still balanced and it's not reducible. So those are the 5 types of reactions and how to predict products. I hope that helped.